In this video, we are going to take a look at one example of how to solve this particular differential equations involving the initial condition y of 0 equals 0. So you are given this equation 1 plus e to the x y prime equal e to the x. How do I solve this differential equation for y? Now recall that y prime is dy over dx. So I can rewrite y prime as dy over dx. And I have 1 plus e to the x on the left hand side equal e to the x on the right hand side. Now I want to isolate the x and the y on two sides. So I multiply both sides by dx. So doing so, I get e to the x and then dx. And now I want to move all the x terms on the right hand side. So now I divide both sides by 1 plus e to the x. So I have e to the x divide 1 plus e to the x and then dx. And now I'm ready to find y. I can find y by taking the integral on both sides. Once I take the integral on the left hand side, I get y. But how do I take the integral on the right hand side? Well, from here you have to use the u substitutions. So let u to be 1 plus e to the x. Then du equal the derivative of 1 is 0, derivative of e to the x is just e to the x, and then dx. Therefore now I can simply rewrite e to the x dx. E to the x dx is simply just du over 1 plus e to the x, that is u. And the integral of 1 over u is simply ln of the absolute value of u. And don't forget to add c. Now you want to write everything back in terms of x. So I have ln, and then u now is 1 plus e to the x plus c. And now in this step we can drop the absolute value side. Why? E to the x, this exponential terms is always bigger than 0, right? This is a positive value. E to the something never negative. And then when you add 1, so the term 1 plus e to the x is always positive. Therefore, I don't need the absolute value side anymore. I can drop that. And then now this is my general solutions. But I am asking for the particular solutions when the value y of 0 equals 0. So now I have to plug in the value. Anywhere I see x, I plug in the 0, e to the 0 plus c. And y of 0 is given at 0. And then e to the 0 is 1. So I have ln of 2 plus c. Therefore, I can solve for c. C is simply just subtracting ln2 on both sides, ln2. So once I get the ln2 for c minus ln2 for c, then I can rewrite my whole answer here as ln of 1 plus e to the x. Let me just move it to the left. Alright, so I have y equal ln 1 plus e to the x plus c, but c is minus ln of 2. And you can use the ln properties. This is the subtractions, so I can go ahead and combine them into the quotient 1 plus e to the x over 2. And this is my particular solution to this differential equations.